is an IoT based baby health and surrounding weather monitoring controlling system using TCP IP protocol. In this project, we are going to monitor the surrounding weather of a baby healthcare centers, especially hospitals, where the baby is placed, and the weight of the baby, certain things like the weight of the baby is also going to monitor, and we are controlling the system using the TCP IP protocol through the cloud. Okay, we are from Andhra Loyola Institute of Engineering and Technology, and mm, he is our guide, and we are the team members. We all contributed ourselves for completing this project. And let me explain the abstract of our project. In this project, an IoT-based baby health and surrounding weather monitoring controlling system using TCP/IP protocol is designed. The Internet of Things technology facilitates the internet to the physical system. With this, we can do the things like monitoring and controlling of the things far distance. The design of any IoT system requires knowledge of transducers, maybe sensors or actuators, and cloud computing, data analysis, wireless data transmission, and reception. In this project, we designed an IoT-based baby health and surrounding weather monitoring and controlling system using TCP/IP protocol. In these overall four sensors, we are used temperature, humidity, a load cell for measuring weight, and a gas sensor, and few actuators are also involved in our project. Here, as per our requirement, one database is created in our cloud, and the data transmission and reception is done from system to cloud and cloud to system using a wireless module with the help of TCP/IP protocol. The operating frequency of a wireless module is 2.4 GHz or 5 GHz, and the IEEE standard for wireless module is 802.11. An IC-based temperature sensor and a capacity-based humidity sensor and resistive-based gas sensor is used in the project, which are helpful to monitor the weather conditions around the baby in the hospital. A strain gauge-based load cell is used along with an amplifier to measure the weight of the baby periodically. All the sensors will give minute analog which requires amplification and digitalization. These digital signals are processed by the microcontroller and uploaded into the cloud through a Wi-Fi module, and its name is ESP8266. This Wi-Fi module will send the data to cloud with reference to application program interface code, API code periodically. The novelty in the design system is the weather condition or the baby weight is not in the range, we can control the things from the long distance with the actuators connected to the system. Now, now I will explain about the basic block diagram of an IoT system. Any IoT system consists of the minimum block diagrams which we have shown here, and the first block consists of the physical parameters like temperature, humidity, and the load cell for measuring weight, and the gaseous sensors. And we can if we go on to agriculture application, we can use the moisture sensor, and these data that all connected from these sensors like transducers, the sensors is converted, like the physical parameters data is converted to electrical data by the sensors, and using this data that we got the minute values of analog data from the sensors, we have sent that data to the signal processing unit where there is an operational amplifier which can amplify the signals, and from then the data or the signals are transmitted to a digitalizer where the digitalizer converts this analog data to the digital data by sampling and the quantization and forwarded to the microprocessor. This microprocessor processes the data, and based on the values it sends the data to the communication technology, like we have used the Wi-Fi module in our project, but you can also use the Bluetooth modules or Zigbee, any of these wireless technologies or the communication technologies for sending the data from the microprocessor to the cloud, and from the cloud we can monitor the values, or we can also control the actuators through internet with the help of TCP/IP protocols. And if the value goes beyond the reference values, then we can control using the systems like Android or iOS, and we have sent the request through the cloud, and from that cloud it sent back to the cloud communication technologies, and from to the microprocessor. This microprocessor will decide, and it will send the instruction to the actuators like motors or the lights. Using this, we can control the system. Hence, the monitoring and the controlling of the system is done in the Internet of Things. And next, this is the block diagram of this current project. Here we have used the sensors, and the sensors that we have used are temperature sensor, humidity sensor, load sensor, and the gas sensor. The sensors gives the value, and the value is sent to the digitalizer, where the analog data is converted into the digital data, and from then the digitalizer to the microcontroller, and from the microcontroller to the liquid crystal for displaying the values. And next, it can send the values to the transmission media, and from the transmission media to the cloud computing, like it will send the values to the cloud, and from the cloud we can see the values through laptops or mobile phones, and we can control the things using the same laptops and the mobiles, and the request is sent back again to the cloud, and through the cloud the transmission media, the microcontroller, and the microcontroller will send the data to the actuators. Now this is the basic circuit diagram of our project, and the microcontroller that we have used is the Arduino Uno, and along with that we have used LM35 for measuring the temperature and the digital humidity and temperature DHT11, and it's a voltage regulator. Since the Wi-Fi module we are using is a ESP8266, and it can handle the voltage only 3.3, not beyond or down the voltage than 3.3, and there is a LCD screen for displaying the data, and here are the connections that we have shown here, and the temperature and the humidity values are collected, and it is shown to the on the LCD screen, and along the Wi-Fi module also we can use. And these are the another two sensors we have used here, and this is the load cell that we are using here, and this is the gas sensor that we have used, and we have connected it to the microcontroller Arduino Uno, and here is a battery source, and it regulates the voltage to 3.3 volts, and it's a Wi-Fi module which sends all the data connected from the load cell and this MQ6 sensor to the microcontroller, and this microcontroller will send the data to the ESP8266 Wi-Fi module. This is the program which we have dumped into the microcontroller for controlling the values, and this is the software serial communication between the Wi-Fi module and the microcontroller, and these are the libraries that we need to add for performing this task, and this is the liquid crystal command for the displaying the data on the LCD screen, and these are the sensors inputs, and these are the humidity input, and it's a MQ7 gas sensor input, it's a weight sensor, and we have initialized the string, and these are the devices that we are going to control further through the internet. And here is a application program interface key, API key, and since we are using a ThinkSpeak website, it's a API key for that, and if you are further doing your project on ThinkSpeak, we need to use another API key from the channel. It's available, and for the command for software serial communication, the pin 10 and 9, and it's a void setup. For the Arduino software we have two actually. It's a setup program, and the loop setup will execute only once, and the loop will execute twice, not twice, the loop will execute continuously. Okay, next in the loop we have, and this is the command for analog read, and it's a temperature, and it's a humidity, and the analog read sensor, and it's a weight, and it's a in check, and this is the command for printing the data on the LCD screen in the serial input, and this is the default case, if any pin is missed from the humidity sensor, it will definitely get to the default case. And next one is the initializing characters. Since we are uploading 4 values, we have initialized 4 strings, and here is a connection that we need to make to connect to the API thingspeak.com, it's a CMD. And next one is the combining. These all are combining. We are combining these all things to a single string, and this is the program for that. Coming to next, it's a send data. Means if we want to get the response from the internet, like for controlling we need to get the data from the internet. For that purpose we are using these commands. It's a different response.index and response.index of linked, and this is the field one of the following channel. We can change the values of the channel if we want to control, and it's a we are using 2 times the AT plus EAP close. And next again we are reading the values, and this is for the second time we are using these values for displaying the data, since we are using the 2 channels for controlling we are using the 2 channels here, and for updating we have used the 4 channels here. And this is the program, and this is the sub program for the send data, and this is the program that we have written, and it's all the program.
This is the hardware setup of the project, an IoT based baby health and surrounding weather monitoring system. Here we are having the sensors, and this is the temperature sensor where it's showing the value T. It's the current temperature now is 28.56 centigrade, and this is DHT11, and this is the temperature cum humidity sensor, and the humidity value it's showing here 44%. It's showing the relative humidity. Relative humidity means the humidity with respect to the saturation point. And the next one is the gaseous levels. The gaseous levels it's measuring here. We are having that MQ7. It's a CO level measuring gaseous sensor, and the weight of the baby that we can measure using this load cell. And this is the structure of the load cell we are using, and the limit of this load cell is the 40 kgs, and the weight that we have taken is this rock. This stone is the reference weight, and it's a 450 grams reference weight. And this is all the hardware setup, and let me show you clearly what's there inside, and I will show you. It's a transformer which is regulating the voltage. It's a step down in the voltage, and we are having this regulator circuit here. This is the regulator circuit, and from that we are taking the supply, and this is the Arduino board. This is called the Arduino board, and this is the HX711. This is HX711, which is used for amplifying the signals that we get from the load cell. And the next one is the Wi-Fi module. ESP8266. See, periodically it's going to upload the values. Okay, and this is all called as the hardware setup, and this is the whole setup. Thank you. Now let us observe the values of the IoT based baby health and surrounding weather monitoring system. And the first field is it's a temperature. The temperature it's showing is the current temperature it's showing is 28.56 degrees centigrade. This is all the temperature sensor in which we have taken by this time. And the next one is the surrounding humidity around the baby, and it's 44%. And coming to the field 3, CO levels, nothing but the carbon monoxide levels we can observe here, and the carbon monoxide levels it's 115 ppm. We can measure the gaseous levels in the ppm, so carbon monoxide levels in the ppm. And the next one is that chart is the weight of the baby chart. Here actually we have taken the reference weight of the 450 grams reference weight. See, the weight of the baby is measured using the load cell, and it's also uploaded, and by this we can measure the surrounding weather and the health of the baby. Now we are going to see how our system can be controlled from a far distance using the internet. See, it's a small website which we have created using the Wix, and here we are having some of the projects IoT 2017, and now currently we have used two devices for switching on and switching off, whether we can use motor or a LED bulb. Okay, and now we are going to switch on the device 1. Yeah, the device is switched on, and if you wanna switch on device 2, we can press again on. Yeah, by this the device is switched, device 2 is also switched on, and if you want to switch off device 1, you can press off. Yes, and if you want to switch off the device 2, pressing off. Yeah, that's it. This is how we have controlled and we have observed the hardware setup here. Thank you. Now let us see how the things can be controlled using internet. See, I have pressed the on button here of your device 1. See what's going to happen here. Yeah, here the LED 1. See, I have made my device LED 1 to the circuit, so that's why it is switched on. And next, let me switch on another device also, then you can get the exact clarity how it's going to happen. See, now I am pressing the device 2 also switched on. See what's going to happen. Yes, both the device, since its execution starts each and every time, both the devices are switched on. See, if we switch on just the device 2, we can press off button. If we press the off button, the device 2 is going to switch off. See, our device 2 is that white. Yeah, just wait. Yes, device 2 is on and just device 1 is continuing its state. Okay, next, if you want to switch on the device 1 also, press the off button of the device 1, then the first device is also going to switch off. Yeah, that's it. See the temperature and the readings now, and this is the load cell. This is the finally I am showing you, and how the things are going to control to the internet based on the values that we have. And these are the sensors, and this is the load cell. And thank you for watching our video.